Okay, let's move on to example number 4. So we have the distribution curve of the soil's grain size, and we already know the D60 and D10. The question is asking for the coefficient of curvature. As usual, you can pause the video for a couple of minutes and work on the problem, and we'll be back. Okay, we're back. So, a very classic soil grain size distribution. And the tricky part is the question is asking for the coefficient of curvature. And we usually use a C sub C for that. And C sub C is not, it used a lot in the grain size distribution and also the soil classification, but it's not an equation that we would be using every day. So this is the part that you might want to look into the reference manual. And so let's look at the reference manual for real quick and find the definition of the C sub C. So go to the reference book, and so this is the definition of C sub C. C sub C is D30 squared over D10 time D60. So we can come back to this one. C sub C is D30 squared over D10 time D60. So if you don't remember what D10, D60, and D30 is, I'm gonna explain this for real quick. So for example, D60, that means it is the particle size that at which 60% of the particles are finer. So same thing for D10. D10 is the particle size that 10% of the all the soils or all the particles are finer. With that, we already have D60 and D10. So the real question is this is good and D10 is also good. And we have to find out the D30, right? So then let's look at this curve together. And this curve is really standard. We have the y-axis as the percent finer by weight, and the x-axis is the grain size in log scale, and we already have the larger number on the left and have the smaller number on the right. And those are from the sieve analysis. I'm pretty sure you have done sieve analysis before in your geotechnical classes. So the way we find D10 or D60 or D30 from the graph is basically we will go ahead and find where the 60% is at, and then find that point on the curve, and then come down, then that will be our D60. Again, we know D60 and we know D10, so the only thing is we need to find where D30 is. So first of all, find that 30% and then draw a line all the way to the curve, somewhere over here, and come down to the x-axis. It's almost here, probably a little bit to the right of this exact line. And then let's find out what this number is. And again, everything is a log scale, so we have 0.1 over here. So this would be our 0.2. This would be our 0.3. And this would be 0.4. And also, this, our actual point of interest is a little bit smaller than 0.4. It doesn't really matter because I'm pretty sure those answers are not close enough to cause any sort of confusion. So you can use 0.4 for calculation, and I would just go ahead and just use 0.39 as a close approximation. So with that in mind, so C sub C is 0.39 squared over 0.49 0.19. So this is a coefficient. Don't really have to worry about the unit that much. And with that, we have the answer close to about 1.63. So C is the right answer. Uh, so yeah, so that's pretty much about it for this example. And one more thing I want to point you guys to is, sometimes you would have the C sub U as well. We all know C sub U is often used together with C sub C in the soil classification. Definition of C sub U is a lot simpler. It's just D60 or D10. Again, the definition of those two, you don't really have to remember it, and I'm sure you can just do a quick search in the reference menu and find the definition of both coefficient. So, okay, so that's it for example number 4.